You know when you stream a movie, make a call to someone halfway across the world, or check the global stock markets? It all happens in a flash. It feels like magic, right? Well, it's not magic. It's actually light, trapped inside billions of miles of glass threads that make up the invisible backbone of our entire digital world. Okay, let's get into how this incredible stuff works. And that's what's so wild. This technology feels like it's straight out of a sci-fi movie, but it's actually built on a discovery that happened over 50 years ago. It's this amazing mix of some really clever physics and just unbelievable engineering that has totally changed the way our world works. So yeah, that's the big question, isn't it? How on earth do you take light, which we all know loves to travel in a straight line, and convince it to follow a path through a flexible cable that might even stretch across the bottom of an ocean? The answer, it turns out, is surprisingly simple and really, really cool. To really get our heads around fiber optics, we have to unlock this one single core scientific principle that makes the whole thing possible. You could call it the secret sauce, the fundamental physics trick that lets us trap a beam of light and guide it pretty much wherever we want it to go. It all starts with something called the refractive index. Now, you've definitely seen this in action before. Think about a straw and a glass of water. See how it looks bent? That's because water has a different refractive index than air, so it actually bends the light that's traveling from the straw to your eye. And this ability to bend light, that's everything. Okay, so here's where the magic trick comes in. If you have light traveling through one material, say the glass in our fiber, and it hits the edge of a different material at a really shallow angle, it doesn't escape. Instead, it reflects back in perfectly, just like hitting a mirror. This amazing phenomenon is called total internal reflection, and it's the secret to making what is essentially a perfect light pipe. So, let's put all the pieces together. Step 1. A tiny laser flashes pulses of light into the fiber. These pulses are your data, your movie, your phone call. Step 2. Thanks to that total internal reflection trick, those light pulses bounce perfectly off the walls inside the fiber, staying trapped. Step 3. That signal then zigzags and zips down the fiber for miles and miles with almost no loss of strength. And finally, step 4. A detector at the other end reads those flashes of light and turns them back into the data you can actually use. Simple, right? But absolutely revolutionary. All right, so we've got the physics down. We know how it works. Now let's peel back the layers and see what these incredible cables are actually made of. A fiber optic cable isn't just a single piece of glass. Oh no, it's a really sophisticated, layered structure. Now it might look complicated, but we only really need to focus on 3 key parts: the core, the cladding, and that outer protective coating. Right at the very heart of it all, you've got the core. This is the superhighway where the light signal actually travels. It's a solid strand of glass, and it has to be unbelievably pure. We're talking about impurities measured in parts per billion. And why? Because any tiny imperfection could absorb or scatter the light, which would totally wreck the signal. Now, wrapped around that super pure core is the cladding. And this is the secret ingredient that makes that whole total internal reflection thing work. The cladding is made from a different kind of glass that has a slightly lower refractive index. That difference is what creates that perfect mirror-like boundary, making sure the light stays locked inside the core for its entire journey. And finally, you have the outer layers. The coating and the jacket don't carry any data, but they are absolutely vital. They're like the armor for the delicate glass inside, protecting it from scratches, moisture, you name it. They're also usually color-coded, which is a lifesaver for technicians trying to organize the thousands of individual fibers that might be bundled into one single massive cable. Okay, so it's a brilliant piece of engineering, we get it, but why did it completely take over the entire world of telecommunications? To see that, we've got to put it head-to-head with the old champion, the copper wire. It all boils down to one fundamental difference. Fiber sends information as pulses of light through glass. Copper sends it as electrical pulses through metal. And that one single difference creates a whole cascade of advantages for fiber. Let's start with signal loss. It's brutal for copper. Over a distance of just 100 meters, that's about the length of a football field, a standard copper cable can lose a staggering amount of its signal strength. We're talking up to 90%. And what about fiber over that exact same 100 meters? It loses just 3%. I mean, come on, that is an absolutely massive difference in efficiency. It means the signal can travel so much farther without needing a boost. And when you lay it all out like this, it's not even a contest. Look at the bandwidth. We're talking terabits per second for fiber versus gigabits for copper. Distance, over 25 miles for fiber versus just 100 meters for copper. It's also way more durable, almost impossible to secretly tap into, and it's completely immune to the electromagnetic interference that can mess up copper wires. It is just total domination. So we know it's better, but think about this. How in the world do you actually make something so precise? A thread of glass that's thinner than a human hair and purer than a diamond. It's an incredible feat of manufacturing. Let's just take a quick peek at how it's done. Well, after that huge breakthrough back in 1970, this amazing process was developed. First, they create a big, solid cylinder of that ultra-pure glass, called a preform. Then that preform is lowered into a furnace and its tip starts to melt. As it melts, a single, continuous strand of glass is pulled from it, almost like taffy. That strand becomes the perfect core and cladding. And get this, each preform can produce up to 5 kilometers of fiber. It gets coated for protection and it's ready to go. You know, maybe the most incredible thing about this technology is just how long it lasts. Because it's glass, it doesn't corrode or break down like copper. The fiber optic network we are laying today is literally being built to last for generations. And its capacity, it's not fixed. It's practically unlimited. We can just keep upgrading the lasers on either end to push more and more data through the exact same strand of glass. It's completely future-proof. So that leaves us with one final thought. We're building a global communications network that's literally made of light. It has a lifespan we can measure in generations and a capacity that we haven't even begun to fully use. The real question isn't about the limits of the technology anymore. It's about the limits of our own imagination for what we're going to do with it next.